So here we're going to do a quick walkthrough of how to solve different types of inequalities. Remember, an inequality is something that has an inequality symbol. And you solve them in a very similar way to the way that you'd solve equations. There's just one big exception, and we'll get to that in a few minutes. So if I have the following, 3x is greater than 15. What I'm going to do to each side to solve it is I'm just going to divide both sides by 3. That's going to leave me with x is greater than 5. And here's how I would represent that on a number line. First of all, it would be a non-filled-in circle over the 5. And then the second thing would be I need to determine which direction it's going for. X is greater than 5, so that means it's going to go in this direction, because everything to the right of it is a solution. Has an infinite amount of solutions, but everything to the right is a solution. And you can just test that out by plugging in one of these values into the original equation. If I plug 6 into this original equation, then I'd have 18 is greater than 15, and that's true. So I know I'm pointed in the right direction. So let's say instead I have this. b plus 15 is greater than 2. We're going to use the way we would normally use solving for equations. We're going to do the exact same thing here. We're going to subtract 15 from both sides. When we do that, we're left with b is greater than negative 13. When I have that, again, I'm going to graph that. So here we go. Once again, it's going to be a non-filled-in circle because it does not have the greater than or equal to symbol to it. If it was a greater than or equal to symbol, that would be a filled-in circle. And it's going to be greater than negative 13. Now, logically, I know it's going to be this way. But if I want to test that out, I'm going to plug in a value over here. I personally like to plug in a value that's easy to work with for me. And so what I do is I plug in anything to the right, but I like to plug in 0. When I plug in 0 into this equation, 0 plus 15, is that greater than 2? Yes, it is. So I know I'm pointing in the right direction because that's the way 0 is pointing. So let's say we have this new problem. Negative 10 is less than or equal to c plus 15. So I'm going to do the exact same thing as I would with the equations. I subtract 15 from both sides. What I'm left with then is negative 25 is less than or equal to c. So now when I graph that, what I'm left with is, first of all, this filled-in circle here, because it's less than or equal to, c is greater than or equal to negative 25, or negative 25 is less than or equal to c. So that part there, the line underneath, means it's a filled-in circle. Now I just have to figure out which way the line goes. So again, I'm going to use 0 as my point. If 0 is plugged into this, does it work? Is 0 greater than or equal to 25? Yes, it is, so it's going to go that way. Now, if by any chance 0 didn't work, then it would just go the other way. So that's the reason why I like to use 0, because it's an easy, quick thing to check. So here's the last type of operation, which is it's a division problem. So how would I solve that? It's going to be multiplication. So I'm left with d is greater than or equal to 15. So again, it would be a filled-in circle. And now let's check that whole 0 thing that I was talking about. Let's see if 0 is a solution here, if I plug that in. Is 0 true about this? No, it's not. 0 is not greater than or equal to 15. So instead of going the 0 direction, I'm going to go the opposite direction, which is this direction, which makes sense. So now we're going to come up to the big exception of how working with inequalities is different than working with equations. So here I have a negative 5c is greater than or equal to 10. So if I were to solve this the regular way, you'd think obviously I would just go ahead and divide it by negative 5. Divide it by negative 5. And I'd be left with c is greater than or equal to negative 2. That would make sense on some level. But let's go ahead and plug in a value and see if that works. Do you agree that 0 is greater than or equal to -2? Well, yeah, it is. So if I plug 0 into the original equation up here, it should work. But -5 times 0 is 0, and that is not greater than or equal to 10. So we've got to switch the direction of the inequality symbol to make it a true statement. Everything else is done the same way. But we've just got to switch the direction of the inequality symbol whenever you divide or multiply by a negative number. So let's try that again. If I plug in this, 0 is no longer a solution. Let's plug in something that would work, -3. Because -3 is less than or equal to -2. So if I plug that in back up here, what I end up with is I end up with -3 times -5, that's 15, and 15 is greater than or equal to 10. I just graph it the regular way. But it's important, really important to check your answers on these, particularly when you're dividing or multiplying by a negative number, because it's likely you'll make a mistake if you don't do that. So here's one more, and here, if we were to multiply this by again, we'd solve this the regular way. We're going to multiply this by -3, multiply this by -3. What we're left with is we're left with -21 over here, then we're left with just b over here. The most important thing is you've got to change the direction of the inequality symbol, because the rest of the stuff is pretty straightforward. So now I'm going to plug in an answer. -21 is greater than or equal to b. So let's see here. If that's the case, let's plug in a number that is less than or equal to -21. So let's plug in -20. Let's make this easier. -27. If I plug that into this equation right here, I end up with -27 divided by -3. That's going to be 9, and 9 is greater than or equal to 7. So I know I have the correct equation here. If I were to make a mistake and instead plug in 0, I can always test 0, and if it's wrong, then I know I'm going the other way. If I plug in 0 to this, I'm left with 0 and -0 thirds, so that's just 0, is greater than or equal to 7. So I know it's not pointing that way when I'm graphing it.